Ever wonder how AI can spot a crack in a bridge, map a city's streets from a satellite photo, or even see through fog? It's all part of something called dense prediction, a fancy way of saying AI learns to see every detail in an image, not just the big picture. But here's the twist. Real-world data is wildly unpredictable. Rainy days, blurry photos, rare medical conditions. These are the challenges AI faces. Today, we're diving into a breakthrough that's making AI smarter, faster, and more adaptable. Let's start with the problem. Most AI models are trained on clean, controlled data. Think of it like learning to drive on a perfectly paved highway. But the real world, it's a stormy road with potholes, construction, and unexpected obstacles. That's where DenseWorld comes in. It's not just another dataset. It's a 25-task lab for AI designed to mimic real-life chaos. Need to detect oil spills in satellite images? Check. Map cracks in a highway at night? Check. Even track wildfires in dense forests? Check. Unlike traditional datasets that focus on scale, DenseWorld is all about diversity and practicality, because AI needs to solve real problems, not just memorize answers. Now, how do you train a model to handle all these tasks? Enter DenseDiT, a smart, lightweight AI that learns more with less. Here's the secret. Instead of building a new model for each task, DenseDiT reuses a single, pre-trained, visual brain. Think of it like a chef who uses the same recipe to make a cake or a pie, just tweak the ingredients. It's called parameter reuse, and it's a game changer. By leveraging existing knowledge, DenseDiT avoids the need for massive datasets, which is a huge win for real-world applications where data is scarce. But here's the real magic. DenseDiT has two helper branches. One acts like a text prompt. Imagine telling the AI, "This is a depth map of a rainy street," and it instantly knows what to do. The other branch learns from examples, like a teacher showing the AI how to solve a puzzle. Together, they let DenseDiT tackle tasks it's never seen before, even with just a handful of training examples. It's like teaching a kid to ride a bike by showing them one video, then letting them figure out the rest. And the results? DenseDiT outperformed state-of-the-art models across all 25 tasks in DenseWorld. While other systems struggled with messy data, DenseDiT adapted like a pro. In one test, it mapped urban layouts with 94% accuracy using just 15 training samples, less than a drop in a bucket. This efficiency could revolutionize fields from self-driving cars to medical imaging, where every second and every data point matters. So here's the challenge. Traditional AI models are like specialists. They're great at one task, say, recognizing cats in photos, but struggle when faced with something new. But the real world is messy. A self-driving car needs to spot pedestrians, read road signs, and navigate fog all at once. That's where mixed-task training comes in. Instead of teaching a model one thing at a time, researchers are asking it to learn multiple tasks simultaneously, like a student juggling math, history, and physics. Sounds tough, right? But DenseDiT isn't just keeping up, it's excelling. Here's the trick. DenseDiT finds hidden connections between tasks. Think of it like learning languages. If you know Spanish and French, you'll notice similarities, like how hello becomes hola or bonjour. DenseDiT does the same with data. Whether it's a foggy road, a medical scan, or a satellite image of a forest, it spots patterns that tie different tasks together. This lets it transfer knowledge between areas, like a super-efficient student who uses what they learn in one subject to ace another. Let's talk numbers, because the results are wild. In one test, DenseDiT tackled fog depth estimation, figuring out how far objects are in a hazy scene, and crushed the competition. It wasn't just slightly better, it was significantly more accurate with fewer errors. And it didn't stop there. When asked to map weed distributions in fields or detect retinal vessels in eye scans, it hit near-perfect scores. But here's the kicker. It did all this using way less data than traditional methods. Think of it as a chef who can cook a 5-course meal with just a handful of ingredients. Imagine a drone scanning a coastline. Traditional models might miss an oil spill hidden in the waves, but DenseDiT, it spots it. Or picture a self-driving car navigating a storm. DenseDiT's algorithms keep it safe, even when visibility is zero. These aren't just lab experiments. They're tools that could revolutionize everything from healthcare to environmental monitoring. But here's the catch. No model is perfect. DenseDiT struggles when tasks are too different, like switching from medical imaging to fire detection. But that's where the real innovation lies. Researchers aren't just building smarter AI, they're building more flexible AI. One model adaptable to chaos is the future. So what's the takeaway? Real-world AI isn't about perfect conditions, it's about flexibility. DenseWorld and DenseDiT show that by embracing complexity and learning smarter, not harder, we can build systems that truly work when it matters most. And hey, if you're curious to dive deeper, the code and data are all open source. Who knows? Maybe you'll be the next to tackle the next big challenge. Thanks for watching. If you enjoyed this deep dive, hit subscribe for more explorations into the future of AI. Until next time, keep wondering.